to start gathering. So, Hugh, now, how do I say your first name?
Hyejin.
Once again?
Hyejin.
Hyejin.
Yes.
Like Hyejin?
Yes.
Cool. I can do it. There you go. So it's a pleasure to have Hyejin today. So Hyejin is actually not so far from this lab as is our scientific grandchild, right?
Yeah.
Because she got her PhD with Hyejin Youn, who was who was the very first postdoc of mine. And who then went back to KAIST and has done very well there, including having fantastic students like Hyejin. And after the PhD in Korea at KAIST, she went to Santa Fe Institute, I believe, and she started out as a postdoc and eventually kind of became a research fellow. She's been spending a few months or some time here at Harvard as well. Lately, that's where I ran into her, not last time, but the one before at MIT, right? And she's about to actually join another former lab member of trying to go from physics and computer science to business school, right? Because she's going to join Northwestern, where we'll be working in the same department in the business school where Dashun Bang is, that many of you know. So she has worked on a wide range of problems, starting with Havon, coming all the way to her recent work on more like on innovation space and networks. So I guess I thought this was a great opportunity to have her here and tell us a little bit what she's actually doing now before she heads off to the College Chicago.
Thank you. Hi everyone. My name is Hyejin Youn. And you may have get the sense of this introduction. I'm a physicist by training, but have been wandering around the different kind of intersectional fields. One of which is linguistics. But the majority of my work were like centered at innovation and organization. But today, besides that, I want to talk about some linguistic work. So. How do I just hang a second? I'm trying to see how I can move on my slide. Somehow it just the computer refused to work now. Just okay. So the reason why I want to talk about it is like, in my heart it's like, so this is a project I really, really enjoy. It's like less to do with what fun me, less more to do with I really enjoy. Because I've been wondering about how I can understand other people's thinking, or how I can let other people comprehend what I'm talking about. So this is kind of magic. Sometimes it's just to me it's kind of magic. How come you understand what I'm saying or what I'm thinking of, and how come or is it possible to understand what my friend is saying? And this is okay. I know what it is. Okay, so the thing is, we have a language, we have a communication under the form of language. I through this speaking or written form, everyone would understand what this writer or speaker is saying. And then the language is the smallest uttered form, in kind of isolated form, unit of the speech is the word, and that's the kind of thing that's the smallest unit that contains some semantic. And then this word, what does this word mean? Word is the things that, there's a particular button I have to push all the time. So the word is, what word is something that takes a form to label concepts in the world. So labeling. So I call this cup. I label the cup. So we create a word to refer to certain kind of concept to communicate with others. That's kind of approach and framework I'm looking at in this line of research. The thing is, this word, and the whole thing is, the definition so far is great, but the thing is, the word and the lexical semantics and all kind of things is kind of squishy, because there is no like extension. There are so many ways to become very ambiguous. So one of the example is, if you look at this and hand and arm. So from where the arm is starting and from where the hand is ending. That's the kind of question we can ask. Another good example is it's a very standard subject matter in semantics. So if you look at these colors, and there are so many ways to divide the color and label them, the names. And also it depends on whether you are, what is it called? Whether, what you're interested in and what kind of culture you're in. You have a different kind of partitioning color scale and to label them. And one of the, this is an example I got it from the online, and like different people have different division of the partition, the way of partitioning color sets and hold them. And that's the kind. Oh.
Yes, just to turn off your Wi-Fi because it's a big country.
Exactly. Yeah.
That's okay. If it comes like next time, just turn your Wi-Fi off.
So that's the kind of starting point. So, as I said, well, there's so many kind of ambiguity, and it's this ambiguity has this whether it's partitioning in a different way, and also this partitioning of different way is a function of culture, is a function of labor, languages, and all different things coming together, and has this kind of creating a lot of ambiguity. And as I said, it depends on the culture as well, or the languages. So that's how you walk into the loss in translation. So this one good example is this, like the bad translation is Korean, Chinese, Korean, English. And can you guess what's this tasteless coffee would mean?
With coffee.
What?
With coffee?
Yeah, that's right. It's like diluted, very not thin, not strong like coffee. So another example is, this is also very philosophical if you read it. This is Korean, Chinese, and English. So it's like, if you look at the Korean, this is the right one. So it's like you walk into this fantastic cave, and then you just somehow because you're walking, you sometimes miss the fantastic scenery. So this is a sign to let you know that maybe you may want to turn around and look how fantastic it is before you proceed out of this cave. But the thing is, it becomes like for a moment back and then twice. And another example is poisonously evil rubbish. This is like the hazard rubbish. So there are so many. So this is the thing. There are so many things that are just lost in translation because we have so much ambiguity, somehow intrinsically embedded in our language and speaking, written in any kind of form. But this is not like this is not the end of story. Of course, even if the same language, English, can be translated from the British and American English. So this is one example. I just took this example because for my personal purpose, because I had when I was in Santa Fe, my boss was British. And then I went to UK, and my boss was American. And then I got the same same thing, like that's very great proposal. And then you're like, oh yes, I'm brave. And then I realized this is something different, totally different. And so there are so many connotations. Also, you have to think about not only language, but also culture, context, and there are so many things that made us to pinpoint what exactly this means. So it's not only just word. Now, to create the more confusion to you is also language. Within this language, within this culture, this partitioning and the semantic itself is actually changed. It's shifting from one meaning to another. So these are the like few examples that I like. The awful it used to mean is a kind of really nice and like full of awe, great, impressive. But now if you say awful, you're awful, then it's kind of like insulting. Silly is another way of looking at this. Silly is used to be like kind of worthy and blessed. Then now if you say silly, then it's kind of silly, right? So there are so many things like changing. It's not only the different kind of compartment and also changing. It's just so confusing and chaotic. So like that's why translator is important and very difficult to do. But now, like as you can see, my title like lost and found translation. Now I'm going to show in this presentation what you can find from translation. So it's like there are so much loss when you translate from one language to another, but there are so many gains you can see that you can't really throw the additional information away. So this is like kind of starting point. So I took it. Okay, this is one example how I utilize this translation. Look at the sun, the concept sun. Sun is a word to label or refer to the bright object in the sky. That's the concept and that's the word sun. But the sun is also the object any kind of language can observe, like speakers of the languages can observe and may have the word for it. So every language has a word for sun, for example. And look at the different languages and the Korean, Japanese, and like Abenaki and Wintu, you have these kind of like he, Vidu, Izos, and Sas, and different kind of forms which refers to the same object. Now, and then you look at this like you go into the Korean, the language Korean, or going to the Japanese, then you realize Vidu refers to not only sun but also day, and he refers to sun but also time. Sas refers to clock as well. So there are so different alternative definitions attached to this sun, the concept sun. Another example is Basque, the fire in Basque. So if you look at the fire, what are the words, a set of words that refer to fire, then you see these different the forms, and then you see these forms also has the alternative meaning: heat, light, match, battle, passion, anger. So now you get this kind of idea. Okay, if you translate and back translate, there are things that are not matching, and you can see these not matching things, and consider them. There is some information contained in this translation and back translation. And this is something like philosophy that if you're a fish, I mean this is like philosophy in Asia. If you're a fish in the water, you actually don't know what water is unless you get out of the water and look in this water. That's the water. I don't belong to anymore. Something like that. So now I want to show you the schematic. What does that mean? So I consider this like translation, back translation will give you some idea how these words are partitioned in different languages. So this is one example. So you have a moon, sun, month, heat, and if you look at the Spanish, then Spanish has this the word luna that refers to moon, satellite, moonlight too, at the same time. So I consider that there is some conceptual space, and you have concepts in your mind, and the words partition this concept and refer to this like the concept at the same time. And these references or the way of partitioning differs by the different languages. So you have this luna, and if you look at the Conceptual, which is refers to sun, then it only refers to the sun, not anything else. And if you look at the Gute in Conceptual, it refers to so many different kind of concepts, including moon, month, sun, heat. So this is kind of conceptual space I'm looking at. If you have any question in between, just ask. Because this is kind of like, now becomes hypothetical anymore. Now, somebody may have heard this universal structure in the human mind, as opposed to linguistic relativity. So what I mean by this is like, one guy, and this guy is Chomsky, Pinker, and Gell-Mann. They are all like, kind of something in mind that human mind should be the same, universal across different culture, across different languages. And that's kind of things like, this guy is trying to look at the universal grammar model, and this guy is trying to look at what's the deep historical, the phylogenetic trees of the languages. But on the other hand, as I just mentioned, that you may have heard of this linguistic relativity, which means if you have a language and the way you understand the word is always formalized by the language, and then also vice versa. So language actually becomes tools, and these tools actually determine how you understand the world and how you utilize your thinking. So that's another way of looking at it. So one of the famous, not the greatest, the worst actually, the famous example is called the sphere of hypothesis. You may have heard of this, like, the Eskimo has 1,000 or 100,000 the word for snow. You heard of it?
It's not true, right?
Yes, exactly, which is actually not true. It was mistakenly understood because this guy didn't understand this entirely different language, the grammars of this entire different language families. So he mistakenly understood these distinctions, although it wasn't actually distinctions of the word distinctions. But anyway, so there are so many ways of looking at it. It's a huge literature out there. It's kind of the reason why I really like this work is that I really like to read these kind of things. One of my favorite example is that if you look at the animation, for example, and these guys, each individual have this voice. It could be female, it could be male. Who the hell decides this guy has to be male and this guy has to be female? I mean, why? Why we are so familiar with this Tifa shoes sounds like female rather than male? What's going on? I mean, if she sounds like male, would it be really difficult? I mean, perhaps it is. So there are a bunch of studies working on this kind of things. Why we sometimes assume certain genders on the object. It can be grammar, like Spanish has this gender grammar, or the German has gender grammar, or it can be just natural, intrinsic ideas in our mind. So another thing is like color gaming. So I previously mentioned that different cultures has different way of pointing out where is the blue and where is green and where is red, and why, and that kind of question can be asked. The thing is, those kind of a lot of wonderful researches are mostly focused on this kind of weird society. Weird means like Western, educated, industrial, rich, democratic. So like something like here, people here. So we study about ourselves rather than actually reaching out beyond this. So when you say like universality, it's kind of dubious. Like especially when you look at the digitized data set, it's mostly focused on the society. So whatever you find may be something to do with this. You can't really say universality in human mind rather than universality in the weird society. So how we can do this? That's the kind of thing we're trying to understand. One thing we have to keep in mind is that it should be systematic comparison. Another thing is, as I said, we want to go beyond the weird society. We want to make a claim beyond the weird society, which means language sample should be unbiased. So that's why you work with a linguist, because if the data becomes now it's kind of tricky. So these are languages. Like for me, 90% of these languages I just don't know. so all my 3 linguist friends actually have collected those data. But the idea is, as I said, we want to make sure that the samples should be unbiased. So we look at the geographics and just make a sampling of geographically, like broad as possible, and also phylogenetically. So geographically, you see Eurasia, Asia, Oceania, America. So you have to see that like equally distributed, and the phylogenetically equally distributed, and the geographically it's not too bad. And then we identify linguistic attributes. So linguistic attributes, what I mean, whether geographically, is it Oceania or Eurasia? So we have the geography, and we also have this whether this the languages are the humid, cold, arid, and these are the number of languages summing up 81. And the topography is like whether the language, the speaker of language live in coastal or inland, and you can also see that whether this language is literate by mean you have written forms in the past, or you don't have written form in the past much. Now, you also have to know a little bit of this. I mean, okay. So now you have languages and you have the words, and as I said, not every concept exists in the different languages, because now we are looking at the languages beyond the weird society. So some society may not have the computer. So if we want to do this kind of thing with the concept of computer or concept of I don't know, the glass, some society may not have any kind of concept. So we want to make sure the concepts actually exist and they're used in the frequently referred as a form of languages or form of words. So there is a great literature out there to make sure what are the list of the concepts that exist universally in different structure over and over. That's what is called the Swedish list. And that's the kind of like universal and the stable, relatively stable, and yeah. So, but we use this Swedish list. From there, as we discussed, translate and back translate, and how these words connected to different concepts. So this is for example, you have a moon and you have a Lakota, and translate, and most of the words in Lakota has this one word, but some of the words has this multiple meaning, which is called the polysemy. And then we use an example, and it has this three different meanings. And then you can construct the networks, how this moon is connected to month, and sun through the word polysemy, week. So that's how the network is connected. Now the problem becomes from this linguistic concept to network structure problem. Now it becomes computation and the mathematics. So that's the concept, that's the model. And of course, if you aggregate everything, now you have a network structure. Now the question is, you can actually explore this network structure and each language and each the continents and language families, all this data set you can find in here, interactive form. So now it becomes mathematics or computation. So now you have a network structure, and you have 81 different languages, and you also have this different kind of linguistic the attributions, and ask this question: is the structure, structure of the network, 81 individual networks, are really random, or there is some kind of structure inside, occur over and over in different language structure, but with some fluctuations, the random fluctuation? That's the first question we're asking. So that's the hypothesis one. And second hypothesis is, if this is not random, is this the variables, the geography or climate, actually has some explanatory power for certain structure inside of this structure? That's the second null model I'm asking. So let me just walk through this later. The third is consider everything is right, and we'll get to that. And then what are the metrics to answer to these questions is if you have a network, different network, and then you can ask, okay, mental test is you have a network, then each node I and j, you can measure the how distance I and j, and you can make a matrix, and each matrix you make a correlation, and then you randomize it according to normal one, and then compare it and ask the p-value. We'll get to that. And second is, okay, the mental test is more like, mental test is more like more like a connectivity from here to there, here to there, here to there, and see how this connectivity preserved across different language structure. But we want to ask how these clusters also conserved across different structures. That's kind of metric we have. Now, the null model. So first null model is the randomized. So you have network structure and you randomize it in a way that, like we randomize switching between two different the node and the link. And then you ask, you use this mental test. So you have a community distance and you have a correlation. And you make a distribution. So H1 is the randomness, the null model. And according to null model, you have randomized, and you compare this correlation. And the correlation, because it's randomized, has this huge distribution of this distance matrix, like this. And then you have the observed one, the actual observed one, network between the American and Eurasia, for example. And then you see the p-value is how unlikely. You can just say that how unlikely or how likely this observed correlation if no model is true. Everyone with me, right? It's kind of confused, but that's how no model works. So p-value is actually really, really small, which means the all the structures are not random. There is some structure that is not explained by randomness. So that's the lesson number. So the null model one is rejected. Now you go to the second. Okay, this is not random. But are these language groups of region or climate, topography, literacy explain any kind of similarity inside of the group? How you can do is the number two, you make a fake groups. So you have a size of Americans, like 20 or like 20 and 10, and then you make a fake size, randomly making group. Fake Eurasia, fake African language, fake humid group. And then you do the exactly same test, mental and the hierarchical cluster test, and do the distribution and find that the null model is not rejected, which means randomness, actually random like fake bootstrap algorithm actually explains any kind of the linguistic attribution. What does that mean? It means there is some structure in the human mind, some structure that is explained by explainable structure, and then this structure is not affected by like whether the speakers of language of these language live in the cold temperature or speakers of these languages live in the literacy or inland and humid, arid, like in the desert. That doesn't matter. This structure somehow is explained by randomness. Now, so far it's we find something. I mean, this is not the way physicists approach. It's more like statisticians do this. But now it's a kind of physics approach. So okay, there is some structure, and the structure is not explained by any linguistic identity. Then what you can ask is, okay, what kind of structure do you want to make a model, like kind of mechanistic model? So first thing first, degree distribution is something skewed. I wouldn't say it's Paolo, but it's kind of skewed. Then we can ask, okay, the degree distribution is skewed, which means some of the concepts are close to each other, like density of concept is heterogeneous. So what I mean by is, so look at the water, is a concept. I have a word for water, and remember the figure I talked about, how the word actually partitions the concept space in your mind. And then there is a concept in the dots, and the water is in focal, and you make a that's the word that refers to the water. But somehow, if the concept is highly densely populated in this around the water, then your language actually, each language picks up these concepts. When you have this word for water, this word refers to not only water, but also to something else, more than others. So that's the water. We have a lot of concepts are caught. And then moon, because it's less populated, you may not have much of the population. So you may not have much of polysemy caught up by this word. So that's kind of like the model. So this is an easy model because it's now kind of a connectivity pattern. So so easiest way to do this is let's consider this, the increase is proportional to the density, and then if it is this null model is explained by how popular this I is a concept. So I is a concept. How popular this conceptual space of this concept I is. That's the popularity. And then alpha is the language, the 81 language. And some language has more ways to cut up this concept, and some languages maybe less. So some languages are getting this smaller ball for the referring to like more some languages are more precise to refer to something. So it becomes a smaller ball. So you only have like small. And some languages are more like broad, like more like lenient about labeling things. Then it becomes this. So you have this proportionality, and then you can make a parameterise reduce, and you can make assume the model. So this is the actual data. So you have 81 languages, and each language you have this population, and then you have this null model based on this full separation model. And then the thing is, you have to take into account randomness. The randomness is you consider this null model is the center point and estimate value, and you can make a multinomial process. And given this probability, you just put the sampling, and this is one sample, and you can generate this 1,000 of these samples, and then with this metric, goodness of fit, the same like mental test and the process. Different kind of test, and it's one of the tests to identify how far away from here to there. So you have a sample to each sample, and then you look at the null model to the sample and null model to data. So we consider this is truth, and this is one observation, and this is hypothetical observation based under your null model. And then you consider distance from here to there, and distance from here to there is 1,000 of distance, and you have a distribution, exactly same thing before. You have distribution, and you have observation, and hence you can measure the p-value. And p-value, unfortunately, although it looks very similar to each other, we are very happy. Oh, we got it, and that's it. And then we find that our goodness of fit actually reject this value. So we look into what was the problem. I mean, because it looks so similar like human eyes. And then we realized, and it actually extended our submission, of course, because of this. And then we realized some of the words actually coding up really, really well. So remember this, this full separation assumes the linear increase of the population's density of the concepts. But some of the concepts is actually saturated quite easily. So these concepts cannot be explained by the linearity. That's the shit. So that was another 3 months extension of our writing paper. Anyway, so according to Einstein, of course, simple is good, but not simpler. So we have to it was very painful as a physicist to make additional parameters. But anyway, so we put another parameter to make a saturation, to satisfy saturation of of course, if you have a additional parameter, you can get a better estimation and better fit. But you also have to make sure this better fit is not really overfitting. So we did a power test and everything. Oh shoot, and that worked, obviously. And so what does that mean? Now you want to say that. What does that mean? So it means there are it's not only the distribution is not only the heterogeneous distribution, but also there is some isolation too. So for example, remember there is water, and if you increase the difference depending on the size, the language size, or the level of preciseness of language, it's increasing, and you have more concepts caught up. But if this water is in a large cluster, then if your language increase, and you got the more concept and caught up and without any saturation. On the other hand, if you look at the moon, which is a little bit isolated from any other concept, then even if your word or your language increase the sampling, you will not cut more than what it was in vicinity, and that's what is happening. I mean, according to our model, I can never be sure. So, so we consider this is not really far away. This structure may not be really far away from our kind of conceptual structure, and that's kind of you have if your concepts C and sort and C and sum is far a different distance, then this distance may be consistent across different languages and the range of the speakers of different languages. So that's kind of conclusion so far we make. And now I'm going to close this, but we are now working on the mythology. So we look at the motifs of cosmicon, the tricksters, female earth and moon, and we look at these motifs and how these motifs are spread the word and through the stories, and whether that explains our human mind and the migration out of Africa. Anyway, thank you. But I have 1 minute, so I'm as Laszlo said, I'm moving to Northwestern, and of course, when someone is moving to new university, there is always opening position, as you say, and if you have something great things to work with me, and I may have something to offer. So just come with me, and Northwestern is kind of really great. And we have a complex system center. And now, next year, we will have the computational social science conference. So it's going to be fantastic. All right, thanks.
Maybe one or two short questions, if anyone.
Sorry, I didn't catch where you were generating fake groups. How did you do the randomization? How did you generate those fake languages?
You mean the first model?
No, the second.
The second model. So you have Post-Simpson is one language. You have a structure, and the Japanese has a structure. English has structure, and then Oceania or the language group will have the group of these languages, right? And the structure of these languages. That's the fact that's already known, the observation. And then you make a fake Oceanian language. So you just randomly, fix the size of the group, and then randomly pick up and make a fake group structure, and then whether the structure is far away or the same within this distribution. That's the question you're asking.
And initially, that one was showing good. It behaved the same as the language groups, but then when we went into the details, that was a problem.
Yeah. So far the normally 1 and 2 says there is some structure, and the structure is not random, and also the structure is not really explained by any kind of additional variable. That's something we know. So consider this structure is there. Now we ask the question, what kind of structural characteristics we can capture? One of which is degree distribution. And the degree distribution has this fantastic hypothesis that whether that shows that has this the density of the concepts. Explain density of concepts. So that's why we use degree distribution. That doesn't mean we explain any kind of different kind of structural characteristics. Wouldn't be degree distribution.
So last
So the translation between languages are human created or some statistical machine learning approach?
Could you?
Translations between languages.
We use dictionaries.
Okay,
Yes,
so
yes.
human created dictionaries.
Yes.
All right, let's thank the speaker again.